Setting up Hadoop to Yarn. In the previous sections, we learned how to install and set up VirtualBox. Then we learned how to set up and configure Linux on top of VirtualBox. In this section, I'm going to cover the real meat, which is how to set up Hadoop 2 Yarn in a single VM so that all the core Hadoop 2 components are up and running. We will also test our installation to make sure all is good with our setup. The primary mode by which I'm going to teach this section is through hands-on demonstration. The reality is this section is more about the operational aspect of Hadoop. As we are going through the installation, I will try to describe some of the Hadoop components, but I won't be able to do justice. Later, we will cover the architecture in more detail. Granted, by the time you're done with this section, you may not thoroughly understand what each of the components may be doing, but it'll give you a good background so when we start discussing HDFS architecture internals and Yarn MapReduce architecture internals, you will start connecting the dots. Finally, don't forget that the goal of this course is to give you a 360-degree view of big data processing using Hadoop, including operational, programming, architecture, and analytics. Hadoop installation. In order to install Hadoop, we are not going to rely upon any proprietary software like the Cloudera Manager or open source tools like Ambari. We are going to do pure hands-on installation, everything from scratch. This will give us a better idea or a good idea as to what's really happening under the hood. And this will be a great learning experience for you. Once you install Hadoop, Hadoop needs to be configured. Hadoop can be configured to run in one of three modes. Standalone mode. In standalone mode, there are no Hadoop daemons that run. The client runs all the daemons within one single JVM. This is great for testing purposes, but you don't really learn much about the Hadoop internals and the Hadoop architecture. The second mode is the pseudo-distributed mode, where all the daemons are running, but they are running in a single node. The advantage is you understand how the Hadoop architecture works and the interrelationship that exists between them. So it's a great learning place or a great learning tool. Cluster or fully distributed mode. In this mode, all the daemons run across master and slave machines. So this is a multi-machine implementation or multi-machine configuration. This is what you would typically be doing in production. So in this section, we will be installing Hadoop in pseudo-distributed mode. And like I said, it's great for learning. Hadoop 2 Yarn components. We looked at the various Hadoop 2 Yarn components briefly. If you recall, they were name node, which was the brains behind the distributed file system, secondary name node, a backup process that allows you to recover the name node and rebuild the image from disk for the name node. Data node, it's the workhorse for the name node, storing and retrieving data in the file system. Resource manager manages the resources in the cluster in terms of CPU, memory, and disks. Node manager, a workhorse for the resource manager that is giving information to the node manager, resource manager about the state of the resources within a specific server. And then job history server, it keeps track of all the jobs that are being run in the MapReduce architecture. In the class website for this week, there is a document titled Steps to Configure a Single Node Hadoop 2 Yarn Cluster in Pseudo-Distributed Mode. We are going to use this document as the foundation to install Hadoop 2 Yarn in a single virtual machine. So let's get our hands dirty and install and configure Hadoop. Okay, so let's log in into HT Server VM as htadmin user ID. The password is htadmin. In order to make it easy for us to execute the steps, I took a copy of the steps to configure Yarn and put it in the desktop. Let me double click on it. It's a 27-step document that describes how you can install Yarn in a single node cluster. Let me make it into a full screen so we can see the document. You may want to take a copy of this document and print it out, and also hold on to it as I'm executing the instructions in order to set up my cluster. If you look at the document carefully, you'll notice that I've also given you commands that you need to execute. If you see a command prefixed with a $sign, that means it needs to be executed as hdadmin user ID. If you see a command prefixed with a $, that means it needs to be executed as root. Let me just quickly go to the end of the document. There are 27 steps. 27th step is to verify Yarn job or MapReduce job to make sure that everything is working fine. Okay, let me leave the full screen. Let me start a terminal so we can execute the various commands. Let's zoom in a little bit so you can see my terminal in action. Okay, so what we're going to do now is execute all the 27 commands so that we can have our Hadoop cluster running, at least in pseudo distributed mode right now. Okay, the first step, step 1, says log into your HD server virtual machine as user hdadmin. We've already done that. If I type in ID over here, it says hdadmin as the user ID. Okay, step 1 is done. Let's move to step 2. Step 2 says update etc host with current host information. Well, it so happens that when you install Linux, by default it does not put the host name in the etc host file. If you don't do that, some of the Hadoop commands don't work quite well because they require the current host to be in the etc host file. Right, so let's do that. Let's execute the commands. If you notice the first command here, it says su-root, so let's become root. The password is root. The reason we wanted to become root is because in order to change the etc host file, you need to be root. Open the file up. Notice it does not have any entry for our server, which is the HD server. So make an entry. I'm using vi. Exit out. So step 2 is done. We have added an entry in the etc host file. Again, this is used primarily for some of the Hadoop commands to work internally. All right, let's move to step 3. Step 3, passwordless SSH login. So we need to set up a passwordless SSH login for the hdadmin user ID because it's the Hadoop scripts, not the Hadoop service daemons itself, rely upon it for performing some operations. So let's execute the instructions in order to set the passwordless SSH login. We need to generate a key. That's the main thing that you need to do here. So let's go to our home directory. CD enter should take you to your home directory, or CD tilde should also take you to your home directory. PWD, there we are in our home directory. Let's generate the key using the SSH keygen command. -t RSA. All right. Take the defaults. So we've generated the key. Do an ls-l.ssh so you can see the private key and the public key has been generated. Now we need to cat the public key into a file called authorized keys. cat.ssh id_rsa pub and cat it to .ssh/authorized keys. You need to make sure you spell this file name correctly, otherwise it's not going to work. You also need to make sure that you change the permission on the .ssh folder and also the authorized keys file. SSH is very picky about security, otherwise it's not going to work. So chmod 700.ssh, chmod 640 on .ssh authorized keys file. Let's also do SSH add just in case. All right, the identity has been added. Now if I do SSH localhost, it's going to ask me, do you want to connect to localhost using passwordless? You say yes, and there it is. We are connected. exit out. Now if I do SSH localhost, it should not ask me for any password. So that means everything is working fine. Okay, let's also do the same thing for HT server, which is the name of our server. Set the SSH passwordless login, set up for that. Do it again, that works too. And let's also make sure that it works for 127.0.0.1. Okay, exit out. Okay, so we're all set. Step 3 is done. Let's move to step 4. Step 4 says we need to set Java home. Of course, Hadoop requires Java to run. We need JDK 1.6 or above. But when we install Linux, it came with JDK 1.7, which is perfect. We can use that. All we need to do is set up the environment. We need to make sure that Java_home is set for htadmin user ID. We also need to make sure that it's set for any other user IDs. It's something that we should set for everybody anyway if we create other user IDs. Right, let's do that. So in order to do this, we are going to create a file called java.sh and place it under etcprofile.d. Of course, etcprofile.d is owned by root. Everything under etc is owned by root. So we need to become root for this. su-root. Put the password as root. And now I should be able to execute an echo command and put the following entry for the Java home environment variable in a file called java.sh. So it's /user/lib/jvm/java. That's where Java is installed. It's actually a symbolic link to JDK 1.7. etc profile.d/java.sh. All right. Oh, let me do it again. I have an extra quotes. Perfect. That should work. In order to make sure that everything is right, I'm going to exit out. And if you source the file, it sets up your environment variable. Let me source the file, do an echo Java home. All right, Java home is set. If I launch a brand new terminal and I type in echo $Java home should be set. Perfect. Java C. All right, everything works. Good. Step 4 done. So we've set Java home. Let's move to step 5. Step 5. Create a folder where Hadoop and related projects will be installed. We want Hadoop to be installed not just anywhere. We want it to be installed in a specific location. In fact, in the future, we are going to be installing Hive, Pig, HBase. They're all Hadoop related projects. So let's create a folder called /user/local/Hadoop, under which we will install all the Apache Hadoop and Hadoop related projects. Since /user/local is owned by root, we need to become root so that we can create a folder called Hadoop. And then what we will do is give the ownership to the Hadoop folder to the htadmin user ID, so the htadmin user ID can manipulate the folder. All right, so let's do step 4. su-root, become root again. Make a directory called user local Hadoop, user local Hadoop. Very good. Let's also create a group called HD group, which is the Hadoop group. So different users that you may have in your system. We're going to have only one user, which is the htadmin user. But if you decide to have other users, if they belong to the HD group, which is the Hadoop group, then they will be able to access all the files and commands that's available under user local Hadoop. So let's go ahead and create a group. It's a good idea to create this group. Group add. HD group. Right, we've done that. Let's change the ownership of user local Hadoop. Let's give the ownership to HD admin user ID and also HD group to the /user local Hadoop directory. Right, so we're done. Exit. If I do an ls-l /user/local/Hadoop, there it is. And if I do an ls-ld, you'll see who owns the directory. It's owned by HD admin. It belongs to HD group. Okay, perfect. Let's move to step 6. All right, step 6, download Apache Hadoop. So now it's time for us to download Apache Hadoop. We can download Hadoop in one of two ways. One is by simply going to Apache Hadoop website. So Apache Hadoop website right there. And then you can click on releases. You can click on download, download a release now, go to a mirror, go to 2.4.1. At the time of this writing, 2.4.1 was the latest release. And you can click on this link right here. It'll download it. It'll place it in your downloads folder. But, you know, we are too cool. We are too cool for this. What we'll do is install this ourselves. We'll do a wget right now. So let's cd to tilde/downloads. So I'm in the downloads folder. I like to place everything in my downloads folder. Let's execute a wget command from the iBiblio website. Wget, that's a mirror site. Wget hadoop/apache/hadoop/common/hadoop-2.4.1/hadoop-2.4.1.tar.gz. Hit enter. There it is. It started the download process. It's going to take a few minutes. I have a slow network connection over here. So what I will do is come back in a few minutes once it's been downloaded. Okay, so the download is complete. Let's do an ls-l to make sure that we have the file. Okay, we have the file right here. It's a tar gzipped file. So step 6, download Apache Hadoop is done. Now it's time to go to step 7, which is installing Apache Hadoop. All right, step 7. All right, the installation of Hadoop is pretty straightforward. All you have to really do is go to /user local Hadoop and extract the file. That's all you need to do. Let's do that. cd to /user local Hadoop tar/z, because it's a compressed file, zxvf tilde/downloads, home directory downloads folder, Hadoop, and hit enter. There it is. It's extracting the file. Hadoop is installed. All right, so we're good to go with that. Now what I would like to do is kind of show you what exactly has happened in terms of the installation and the installation directory structure, so you have a better idea. You can launch the file browser right here. So that's the file browser icon. It's like the Windows Explorer. I would like to go to the file system root and go to user local. So here's user local Hadoop. Underneath it, there's Hadoop 2.4.1. So these are the the directories that are created under Hadoop 2.4.1. There's a bin directory which contains commands like the Hadoop command, hdfs command, also the yarn command. These are the commands that users end up using. Users of Hadoop use those commands. There's also a directory called sbin. Don't confuse bin with sbin. These are commands that are used by Hadoop system administrators. So it has commands to start daemons like Hadoop daemon.sh that starts one daemon, or Hadoop daemons.sh that starts multiple daemons in one command, and then starting all the daemons, shutting down all the daemons. By the way, it's these commands that required the presence of HT server, which is our host name in etc host. And also, it's these commands that require SSH passwordless login. That's why we did those setup things in the beginning. Right, let's go back. Let's explore a little bit more on the installation. There is also a folder called etc Hadoop. This is where all the configuration files are kept. We are going to now start doing some configuration of Hadoop, and most of the configuration files are over. In fact, all the configuration files are over here. That's what we'll be manipulating. There is also a folder called include that contains some header files if you're interested in C programming, whether it's MapReduce C programming or HDFS C programming, which we are not going to cover, but it's available for you. There is also a lib folder that contains all the native libraries. These are for C programming purposes. There is a folder called libexec that contains internal Hadoop commands that the Hadoop shell commands use. Then there is the share folder. Share folder has the documentation. So if you want to know where the API documentation is, or other related documents, they're available right here. The share folder also has a Hadoop folder that contains the major modules and the libraries associated with those modules. For example, the common module. Here's the common module jar file, and the dependent jar files that the common module depends upon. They're right here. We'll be adding all these things into our class path when we start doing Hadoop programming. So just wanted to kind of show you where these things are. You might want to take a few minutes and walk through the directory structures so you can get an idea as to how things are organized over here. Right, I think we've gone through pretty much all the directories that are part of the installation. Okay, let me close the file browser. Right, so we have installed Apache Hadoop. We're good to go. Let's move to step 8. Okay, step 8 says make data and log directories. Now, Hadoop needs certain directories where it places data files. So we need to make that special directory, and also we need to make a directory where log files can be placed for all the daemons. So let's do that. The commands are right here. mkdir /user local hadoop /data/nn. This is where name node is going to place all the name node related information. I need to do make dir -p because the path is not there yet. All right. I also want to make a directory for secondary name node, and I also want to make a directory for data node. So nn is where the name node places all the files necessary for name node. SNN is where the secondary name node places all the configuration files for the secondary name node daemon, and dn is the directory where the data node places all the data files. Don't worry about these directories right now. We will talk more about them when we get into the HDFS architecture section. But the important thing for you to understand right now is these directories are needed for configuration, and then we will see how the daemons use these directories when they start executing or when they start performing the MapReduce or the HDFS operations. Okay, so we are done there. Now we need to make a log folder, user local Hadoop 241 logs. We are making a folder called logs under the 241 directory itself so that we can have all the daemons place their log files over there. Okay, we're good with that. So we're done with step 8. Let's move to step 9. Step 9 says configure course site.xml. So now we're going to get into configuration. Remember, Hadoop has common, HDFS, yarn, and MapReduce as the four major modules. So we will have to configure each one of them. That's what we'll be doing right now. Let's configure core site.xml. Okay, so for that we need to be in the etc Hadoop folder under Hadoop 241 installation. Remember I mentioned to you all the configuration files are kept under etc Hadoop. So let's go over there. cd/user local Hadoop 241 etc Hadoop. Let's go to that folder. And we want to vi a file called core-site.xml. That's where the common module is placed. Open the file up, and to make it easy, I'm simply going to copy the configuration, paste it right here, edit, paste. There we go. Property, the property name. These properties have a name value pair combination. So property, there's only one property we have in this file. It's called fs.default.name, which is file system.default.name. We are going to be using the HDFS file system, and the HDFS file system is running on port 9000. This is pretty much the port for the name node. All right, we are done with that. So we have configured core site.xml, which is the common module. Let's move to HDFS site.xml, step 10. Right, vi HDFS site.xml. We are in the same directory, so we don't need to cd to any other folder. I'm going to copy that again from this file. All the properties from here. Copy and paste it right here. Edit, paste. So you don't really have to make it look pretty, but I like to do that. So the first property is dfs.replication. This is saying that since we only have one node, we only want to store one copy of every block or every file. If we had more than one node, then we would set it to 2 or 3. The default value is of course 3 for every data node or data block. It'll store 3 copies of that particular block. The second property is where the name node is going to store all the name node related metadata information. The next property is the checkpoint property. This is where the secondary name node is going to store all the secondary name node information. It's very similar to what you have in the name node, because secondary name node is like a backup name node. And the data node directory is where the data node daemon stores all the data associated with the block. All right, don't worry too much about what these properties really mean at this point. We'll come back to this when we start talking about the HDFS architecture in more detail and the HDFS internals. Okay, so we are done. So we've configured HDFS site.xml. Step 10 is done. Let's move to step 11. Step 11, configure mapred-site.xml. We are configuring MapReduce. Once again, it is again in the etc Hadoop directory. We are right there. vi mapred-site.xml. You'll notice that mapred-site.xml doesn't really exist because Hadoop Yarn is an architecture where you can run MapReduce. You don't really have to run MapReduce, but MapReduce is the most important framework, and it's the only framework that comes with Hadoop. So what we'll have to do for that is move the mapred site.xml file template into a file called mapred-site.xml so that we can configure it. Let's open it up and configure That's site.xml. All we want to say here in this file is that we are going to be running MapReduce under yarn. So copy that entry, paste it right here. This is a very simple XML file. This XML file says the framework we're going to be using for MapReduce is the yarn framework. Okay, we are done. So step 11 done. Let's move to step 12. Step 12 says configure yarn-site.xml. So we need to configure the yarn daemon or the yarn module. Okay, so for that, let's open up yarn-site.xml. Once again, in between the configuration directory, let's go ahead and copy all the yarn related properties. Okay, there's a property here. One thing you may have noticed, every property has a name value pair combination. There is also one more attribute or one more tag that goes inside the property tag, which indicates whether a property is modifiable or not. We'll look at that when we talk about Hadoop configuration. Okay, so beware of this. You cannot have any spaces. This is a fully qualified class name. So basically in this configuration file, you're saying that you want the yarn node manager, which is a daemon, to run an auxiliary service called the MapReduce shuffle. When we talk about the MapReduce architecture, we'll talk about the shuffle stage. And it says what is the name of the class that is going to be doing the MapReduce shuffle. Right, so that's the MapReduce configuration under yarn config. So we're done with that too. If we made any mistakes in our configuration when we start the daemon, we're going to see those error messages, so it's not a big deal. Step 12 done. Let's move to step 13. Step 13 says modify Java_home and Java heap sizes. So there's a bunch of environment shell scripts that are out there that we need to modify. We need to modify it for a couple of reasons right now. One, because you have to make a change for Java_home environment variable. And the second reason is because we are running in a virtualized environment, we don't really have enough memory. So many of the daemons expect to run with 1, 2, 3 gigabytes of RAM. So we're going to bring those values to about 500 megabytes. Okay, so let's go ahead and make some changes. These are changes to the environment variables. Again, they are in the same directory as the configuration files under etc Hadoop, and we are right there, so it's perfectly fine. Now we need to go to the Hadoop env file. Let's go to Hadoop env file and open the configuration. We need to change the Hadoop heap size. Let's search for heap size. There it is. Change the value, first of all, uncomment it and put the value 500. You can put it within double quotes if you want. You don't really have to if it's a single word. Change these two to a value of 500. We're good to go there. Then we need to open up MapRed env. This is the MapReduce env file. And change history server, which is a job history server. It's right there. Change its heap size also from 1000 megabytes, 1 gigabytes to 500 megabytes. All right, we're good there. Now let's change yarn-env.xml. .sh, not XML. Change the heap size there, -x mx right here. It's 1000 megabytes. Change that to about 500 megabytes. All right, that's one change. Oh, we also need to change the yarn heap size. Search for yarn heap size. Next, right here, we need to change that. We need to uncomment it and change that value to 500. All right, we're good with that. So we've done the changes related to the environment variables for the daemons. So step 13 is done. Let's move to step 14. Okay, step 14, format HDFS. For HDFS name node to come up, it needs to initialize the directory where it holds the HDFS related data, all the metadata information. And that directory is actually /user/local/hadoop/data/nn. It's a directory we created. We also configured in our in hdfs-site.xml file the directory name. Now it's time to initialize the file system by formatting it. For this, we need to be in the bin folder. So cd/user local Hadoop 241 bin. In the bin folder, there's a command called hdfs. So /hdfs name node -format. It's formatted. Going through the format process. It says right here, storage directory user local Hadoop data and then has been successfully formatted. All right, so we have our file system formatted. So step 14 is done. Let's move to step 15. Step 15 says start the HDFS name node service. All right, so now we need to start the name node daemon itself. We need to be in the sbin folder. So by the way, if you recall, the sbin folder is parallel to the bin folder. So I'm just going to type in cd.sbin, and that's going to take me to the sbin folder right there, which matches the folder name that's listed over here. All right, let's start the daemon. /hadoop daemon.sh start name node, because we want to start the name node daemon. There it is. So hopefully name node will run. Name node has started, and its logging information placed over here in the HT server in this particular directory. Notice the logs folder we created. So all right, so we got the name node working now. Step 15 done. Let's move to step 16. Step 16 says start the HDFS secondary name node. So it's time for us to start the secondary name node. Secondary name node. So we'll change this to secondary name node. All good. Step 16 is done. So we've started the secondary name node. Let's go to step 17. Step 17 says we need to start the data node service. Let's do that. Start the data node service. All right. So that's done too. Step 18 says verify that all the daemons are running. We can verify all the daemons are running by typing in JPS, and we see name node, secondary name node, and data node running, and those are the process IDs. So everything is good. In case something did not come up, all you need to do is go to the log file. So for example, if you wanted to view the log file for the name node, you can say view user local Hadoop 241 logs, and the name node log file would be Hadoop. It always starts with Hadoop for name node, hd admin -name node hd server .log. There's actually a method to this madness. Hadoop is the prefix. Sometimes it'll say Hadoop, sometimes it'll say MapRed, sometimes it'll say Yarn, depending upon what kind of service it is. And then it'll tell you the name of the user ID, which is htadmin in this case, the user ID with which the daemon is running. Then it's going to tell you what is the daemon that you're dealing with. In this case, it's name node. And then it has the name of the server where the log file is placed. So there's a method to this madness in terms of the log file names. View the file. There it is. Go to the end of the file. Everything seems to be up. Everything seems to be working. We're good to go there. All right, step 18 done. Let's move to step 19. We have 27 steps to go. We're almost there. Start the Yarn Manager service. Start the Yarn Resource Manager service. Okay, so cd to sbin directory, which is where we are right now. And we're going to start the Resource Manager daemon, yarn dash. Okay. And if you're wondering how I'm able to type some of the commands so fast, it's because I'm using autocomplete. If you hit the tab, it auto-completes the file name. Start Resource Manager. It's going to start the Resource Manager. Resource Manager has been started. Step 20. Let's start the Node Manager. All right. It uses the yarn command again. Start the Node Manager. Node Manager has been started. And we can actually execute the JPS command to see if those things have been started. Data node, secondary name node, resource manager, name node, and node manager. All the 5 daemons have been up. Okay, so step 20 done. Let's move to step 21. It says start the MapReduce job history server. There is a server called the history server that tracks all the different jobs that are running under MapReduce management. We'll see the UI for that later on. Okay, let's start the job history server. The job history server is started with a special command called the mr job history daemon. So again, it's in the sbin directory /mr job history daemon.sh start history server. Let's go ahead and start the history server. There it is. History server is up. Step 22 says verify that all the daemons are running. The way we verify that is by typing the JPS command. So type in JPS. We got name node, which is the master for the HDFS, data node, which is the slave for HDFS, secondary name node, which is like a backup name node. We have resource manager, which is the master for Yarn service. We have node manager, which is the slave for Yarn service. And we have the job history server, which is for MapReduce. All right, so we're good. Step 22 done. 5 more steps to go. So step 23 says, check out the HDFS name node UI. Now, for the name node, resource manager, and history server, there's a really nice UI that you can go to. And the UI for the name node runs on port 50070. So we can launch Firefox and we can type in localhost 50070. We see the web UI for name node. Next week, when we start talking about HDFS, you will see more about this UI and understand what this UI is doing and what these different summaries really mean. All right, so that indicates to you that the name node is running and we also have a UI. We can also launch the UI like this. You can type in Firefox http://localhost 50070. It'll launch Firefox and it'll take you right to the page. All right, so we know that the name node UI is working. Let's go take a look at the Yarn Resource Manager UI, which runs on port 8088. So let's change this to 8088. Yep, Yarn is working. There are no applications that have just submitted jobs to Yarn yet. So Yarn Resource Manager is up and running. Now let's go ahead and check to see if the history server is up and running, which is step 25. History server runs on 19888 by default. You can change all these port numbers in the configuration file if you want to. Here's the history server. No job has been submitted. That's why it's all empty. So the history server is also running. So we've done 25 out of 27 steps. Step 26, 2 more things to do. Step 26 says, let's perform HDFS operations on command line to make sure that our HDFS is working. Don't forget, HDFS is a distributed file system. It takes the disks across multiple machines and makes it look like a single file system. Of course, in this case, we have a single virtual machine and the disk is just the local disk. But still, we need to make sure that it's working because it's a pseudo distributed mode. So let's go ahead and do that. Let's cd to downloads. And the reason I'm going to the downloads folder right now, because I want to download a file from the internet, and then I'm going to put that into HDFS. All right, the file that I want to download is the Moby Dick book from the Gutenberg.org site, which gives you free text file versions of many of the classic books. So wget gutenberg.org/cache/epub/2701/pg2701.txt and hit enter. There it is. It's downloading Moby Dick, the text file version of it. It's a pretty fast download for me, so I'll just go ahead and wait. Okay, we've downloaded the file. I'm going to open the file up. There's the file right there. Cool. That's the Moby Dick book. So what I want to do now, I have the file again in my downloads folder. What I want to do is I want to put this file into HDFS. So what we'll do is make a directory called /in in HDFS and then copy the file inside it, and then we're going to run a MapReduce program. That would be the last step. All right. So let's do some HDFS operations since we are in step 26 right now. The way you execute HDFS commands. Again, next week when we get into HDFS programming and architecture, I'll show you how to execute these commands in more detail. But right now, the way you execute a command is by using HDFS. Right, so let's do that. For that, we need to be in the bin folder, cd/user local Hadoop 24 bin. There is a command called HDFS DFS and makedir-makedir/in. So basically what I'm doing is executing the HDFS command, passing the DFS as a subcommand, and then executing a command called mkdir. So I'm making a directory called /in in the HDFS file system. Let's do that. This is the first time we are executing the HDFS command. If I do HDFS DFS-ls/, it's going to show me the root directory within HDFS. Remember, HDFS is a virtual file system. There's a directory called in over there, and there's a directory called tmp. It's by default created by HDFS. If I do /in, there is no file in HDFS. So basically what I'm doing is manipulating the HDFS file system at this point. What I would like to do is copy the book, Moby Dick book, into this directory. So let's do that. There will be HDFS command distributed file system DFS, And by the way, it says DFS here. If you're working with Amazon, the Amazon S3, it would be S3 for that. -ls slash, not ls, it's going to be copying a file. So it would be copy from local tilde slash downloads PG, that's the book, and I would like to copy this book, UTF-8, I would like to copy this book into /in slash mobydick.txt. So I want to take this file and copy it into the /n folder as mobydick. Okay, it should be dick.txt. Hit enter, and that's going to execute the copy from local command, basically saying copy from the local file system into HDFS. So to prove that this worked, do a dfs ls command in /in folder, and yes, the file is located. There's a copy of the file over there. All right, so we were able to install Hadoop, we were able to configure Hadoop, we were able to launch all the Hadoop daemons when you did JPS. Notice there are 6 daemons that are running. We have Hadoop running in a pseudo distributed mode. We're able to manipulate the file system. We're able to create a folder. We're able to copy a file in the HDFS file system. The last step is run a MapReduce job. So we're going to submit a MapReduce job. We're going to submit the classic MapReduce job, which is do a word count operation. We are going to go through the mobydick file and pull out all the words and figure out what the occurrences of each words are. Okay, let's do that. So for that, we need to be in the bin folder, which is what we are in. In order to run a MapReduce command, you need to execute the yarn command. So yarn jar user local Hadoop dash 2.4.1 / share / Hadoop / MapReduce / Hadoop MapReduce examples 241.jar word count /in /out. Okay, so here's what I'm doing. I'm saying I would like to run a yarn job, passing to it a jar file, which is this long jar file name called Hadoop MapReduce examples. That jar file contains a MapReduce program called word count, passing the name of that particular program, which takes in a directory, which is the directory that contains the file. In this case, the mobydick file is located over there. And then I would like the MapReduce program to run in the cluster in pseudo distributed mode and place the output in the out folder. Let's see if that's going to work. So when I do that, it is going to submit a job to the resource manager, which is going to talk to the job history server, which is going to talk to the node manager. So all the communication is taking place right now. The job is being run, and if everything is right, we are going to see a directory called out, hdfs dfs /out. We're going to see a directory called out, ls /out. Yes, we do. In fact, if I do a slash, you see the /in /out and /temp folder. We only had the /in /temp folder a few minutes ago. Now an out folder has been created because the MapReduce job ran and the output got placed over there. Right, so let's go look at the out folder. In the out folder, there is an output success file, and there's also a part file. The part file is the one that contains the MapReduce output. Let's take a look at the file, and there's a really nice command called cat. So it's dfs command called cat. We want to cat the /out /part-r. Why does the file have a name of part and r and 000? We'll talk about those things in MapReduce. For the time being, just notice that it's the output of the reducer. and there's only one reducer, and that's reducer 0. If I do a more on that, I should see the output. There it is. Here's all the words and their count in the Moby Dick book. So if you want to know how many times the word, let's say, beautiful appeared, beautiful, it doesn't exist. Let's say and, sure, and exists. And exists 321 times, and comma exists 13 times. It hasn't really removed any of the stop words, but you get the idea. Okay, so in this section, over 27 steps, we were able to install Hadoop, configure Hadoop, launch all the daemons, test the HDFS service, and test the Yarn service. So we're good to go.